So this titration problem says a 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar CaOH2. What was the concentration of HCl in the original solution? Our first step is to write out and balance our equation. HCl is a strong acid and CaOH2 is a strong base. That means HCl and CaOH2 completely break apart into ions when in solution. Now that we have our balanced equation, we can draw a picture to represent the reaction. On the left, I have HCl solution with a volume of 0.075 liters and the concentration we are trying to find. On the right, I have CaOH2 with a volume of 0.0273 liters and 0.57 molar. I have crossed out the H in HCl and the OH in CaOH2 because those two ions will make the precipitate in this reaction, which will be H2O. Before we start the problem, we know the volume of HCl and the volume and concentration of CaOH2. We know we need to find the moles of HCl, so then we can put it into the equation moles divided by volume equals molarity and find the concentration of HCl. To get moles of HCl, we first need to find moles of CaOH2. To do this, we'd use the concentration of CaOH2 and the volume of CaOH2 and solve for moles. When we solve for moles, we get 0.004281 moles of CaOH2. After we found the moles of CaOH2, we can now find the moles of HCl using a mole-to-mole ratio by looking at the chemical equation. In this case, we are converting 1 mole of CaOH2 to 2 moles of HCl, and we end up with 0.0085722 moles of HCl. After finding the moles of HCl, all we have to do is plug it into the equation moles divided by volume equals molarity, and our final concentration for HCl is 0.144296 molar. Some common mistakes associated with this problem is that moles of HCl have to be found using the mole-to-mole ratio by looking at the chemical reaction. Another common mistake is that M1V1 equals M2V2 cannot be used in this problem because you have to convert moles of one reactant to moles of another reactant.